Hello everybody and welcome back to Mikebaba-CATIA for part 2. To our line tool mastery, we are tackling the powerful methods today: angle, tangent, normal, and bisecting lines. We will also clarify the critical bitangent functions and the correct use of geometry on support. If you are ready to create precise reference geometry in CATIA V5, let's jump right in.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate.
Hello everyone. We continue the lesson on drawing a line in space. Consider the shape we created last time. I right-click on the curved line that we had before. From the opened menu, I select Properties. I click on the Graphic tab. The graphic window opens. This window has 4 sections. Fill, edges, lines and curves, and points. Now we want to change the graphical parameters of the line. So we are working with the parameters in the lines and curves sections. I click on the V symbol under color. I select the blue color. I click on the V symbol under thickness. I select a thickness of 1 mm. Now I activate the point command. I set the creation mode to on curve. I click on my curve. I create a point on the curve. I also change the color and shape of the point through properties. I activate the line command. I set the line type to angle, normal to curve. In the first box, I must select a curve. Now the box in front of it is blue. I click on the curve that is blue. Now the support section is active. The software asks us to define a support surface. Important: in this mode, the support is used as a reference surface from which the angle of the line will be measured relative to the curve and the point. Note that if you select a surface on which the curve is not placed, a warning will be given to you. First, I consider the XY plane as the support. This warning tells you that the curve is not located on the surface you have defined. I click OK on the warning window. You see that the word support is written in red on the XY plane. Now you see that the box in front of point has become active. The software is waiting for us to introduce a point to it. The start of the line can be from this point. I introduce the point on the curve to it. Now the box in front of the angle is blue. I give an angle value of 45 degrees in the box next to angle. Pay attention to the start box. Its value should be 0 now. If this number is 0, the line will start from the point on the curve. If the number is other than 0, the start of the line will be offset by that amount in the positive or negative direction from the point on the curve. I also give a value of 150 in the box next to end. I click OK on the settings window. The line has been drawn. I rotate my volume in a space. You can see that the generated line is not located on our surface. I double-click on the line's name in the design tree to open its settings window. Now in the support box, I select the top surface of my volume. I click the OK. I rotate the object in a space. You see that the line is still straight. It simply starts from the point and is drawn according to the angle, ignoring the surface shape. I double-click on the line's name in the design tree. Its settings window opens. In the lower part of the settings window, we have an option. The option's name is Geometry on Support. I activate its tick box. I click OK. You can see that the line is resting on the surface. Here, where the line is resting on the curved surface, it no longer has the shape of a straight line. The line's shape has changed into a curve. Note, every time you use a support, the shape of the line will follow the shape of the support. Now I double click on the line's name in the design tree again. Its settings window opens. I remove the tick next to Geometry on Support option. I click the OK button. You see that the line is not on the curved surface. But it has taken the shape of a straight line. I delete this line. Another line drawing mode is called Tangent to Curve. In this mode, I can draw a line tangent to a curve at a specified point. First, I create a point on the edge of my shape. Now I activate the line command. Its settings window opens. I set its drawing mode to tangent to curve. In the first section, we have three options: curve, element, and support. Now the box next to curve is active. Here I click on the curved edge of the object's shape. Now the box next to element turned blue. Here I must click on a point from which the line will be drawn. I click on the point I had created. Now the box next to support turned blue. If I click OK here, ignoring this option, a line tangent to the shape's edge at the specified point will be drawn. Now I double click on the drawn line. In its settings window, I click in the box next to support so it turns blue. I click on the curved surface of the shape. The line takes shape on the edge and as a curve. Below these three options, there is a section called Tangency option. The default mode is Mono Tangent. This mode is for drawing a line tangent to one curve at a specific point or element. The other mode is called Bitangent. To explain this option, first, let's remember what a tangent to a curve is. A tangent is a line that touches a curve at only one point without intersecting it. To define this line in addition to the curve, you usually need a point or a direction. A bitangent line is a line that is tangent to two different curves at the same time. Let's say we have three circles on the page. I rotate the page a little to better see the position of the circles. Two of the circles are on the same plane. First, I activate the line command. I set the line type to tangent to curve. Now in the tangency option, I'll set the type to bitangent. I click the box in front of the curve so that it turns blue. I click the first circle. I activate the box in front of element 2. I click on the second circle. I press the preview button. You can see that 4 lines are shown as a preview. One of the lines is orange and the others are blue. The orange line is the line that is selected. At the bottom of the window, you see a button called Next Solution. Each time you click on this button, another line will turn orange. If you click on OK, the orange line will remain and the other 3 lines will be deleted. Note, our 2 curves must both lie on the same plane. For example, if instead of the second circle, I click on a circle that is on a different plane, I will get an error message. Now I will show you the same command on the edge of 2 cylinders. I return to the previous shape. I draw a point with a distance from the point we have. I activate the line command again. I set the line drawing mode to normal to surface. In the settings window, I must introduce a surface to the software. I click on the top surface of my object. Now the software waits for us to introduce a point to it. I click on the point on the surface. I click OK. You see that a line perpendicular to the surface at the determined point has been drawn. I activate the line command again. I keep the drawing mode as normal to surface. I click on the surface. Then I click on the point outside the surface. I click OK. You see that a line perpendicular to the surface is drawn from the point outside it. Now consider that we have two intersecting lines. We want to draw their bisectors. I activate the line command. I set the line drawing mode to bisecting. In this mode, the software asks us to define two lines. By defining them, the software shows their possible bisectors. If there is more than one possible bisector, it shows one in orange and the others in blue. In its settings window, there is also a button called Next Solution. By clicking on it, you can change the selected bisector. Now I activate the line command again. I set the drawing mode to bisecting. This time I select the two vertical lines that I drew. As soon as the second line is selected, an error appears. In its window, it warns us that two lines do not have an intersection point. I click OK on this window. Now you see that in the line settings window, the box next to point is active. If I click on a point here, the software uses this point to define an imaginary plane where the bisector line can be created. The software immediately shows me two bisecting lines within that plane. So, if you want to create a bisector between two skew lines, you must also define a reference point to specify the plane for the solution. This point can be anywhere, on one of the disjoint lines or a point at one of the corners of the figure. Very well, today's lesson is finished here. Please watch the lesson several times. Practice along with me. Good luck, goodbye until the next lesson.
Coco. Let's build the future. Come with me.